You know what? I think I was supposed to start already. Now, welcome to episode 5 of The Philosophy of Nature, my new favorite program, show, program. Now, this is one of the cases where this whole distinction seems to be growing in importance about the new viewers and the old viewers. Not that I want to create divisions. You should all be one big happy family, but obviously there's going to be, big divisions. And this is one of those cases because my old viewers might think of me as, defending physics, maybe defending a physics they have attitudes about that it's, foo-foo or that, it's too rigid. Could be the opposite, that it's militaristic or whatever. Somehow traditionalist, whatever you think of traditionalism, or not old traditionalism but modern, I accept what the physicists say. Now I don't endorse every single thing they say because they're all over the map, right? A lot of people don't know that, I guess, but they're all over the map. Scientists disagree on everything and cover the spectrum, except for they'll agree on what the data is, at least after a certain point. If it's just one person has done an experiment, no, but once it's been repeated and maybe it becomes famous as, and they show it to students and students repeat it and they refine it and do more sophisticated versions of whatever experiment it might be. And I was thinking about this as a sidelight. It's funny how some people will be like, they've never redone that experiment because they changed the experiment. It's like, can you ever redo the original two-slit experiment? It was done with candlelight. Now they use lasers or whatever. It's being refined. And anyway, in this during this process, all of these people that disagree on what's going on, the interpretation of what's going on, they're doing that from the same data. They agree on what the data is that they're trying to explain. And, it's kind of annoying. It's kind of annoying with people create a conspiracy theory where somehow they all just somehow agree or have a common interest in pretending that they've done experiments for a century. We haven't done any yet. We're really thinking about it. Okay, so I happen to, this is what's the shock. It's not the new viewers that are going to be confused, it's the old viewers. This is what the shock. You should have actually been able to see from what I've been saying. I have my own theory where I differ from common interpretation. We've seen it in the organic issue of what's alive. But or rather, what I mean, whether living things all have consciousness of some small sort, nano consciousnesses. I will differ with popular interpretation. I don't differ with the data. An example from anthropology, I think that's what you would say the subject is, I've always kind of had a suspicion that people didn't get to North and South America just over that Alaska land bridge. I mean, I believe that they would come across the land bridge if it existed, and it seems to have existed. But the Polynesians covered and occupied every habitable island in the Pacific, all the way up to Hawaii. And there just aren't many other than in the South Pacific. But a huge area of land, of sea, a huge area of the earth. And I always thought they landed over in South America. And a lot of people, it turns out, have believed that over the years. And there's some evidence, like hens, that's in South America that seemed like they might have come from, um, Polynesia. But then they're doing genetic studies, and when they eliminate my idea, it'll be like, oh, okay, I guess that theory didn't work out. I can't do the research, but I can come up with theories that are interpretations they haven't made yet, and then see how it goes. And sometimes they go rather well. Like I predicted, quantum mechanics would show up in biology my whole life since I discovered quantum mechanics, because nature always thought of it first. It's going to be co-opted in fucking nature, obviously. And, it wasn't until, I don't know, I'd been talking about it on YouTube for a couple years, and they started finding it in, um, what is it, chlorophyll? And pigeon homing and magnetic homing and various things. And obviously, but it could go either way, and I'm fine with that. Now, here's my physical theory. I think that space is probably particulate and discrete. So space is like these bubble pictures, especially this is a good one. Hmm. It flashes, I guess, when the cursor is over there. Well, nothing I can do about that. But anyway, it's this kind of thing. This is what space is like. Filled with cells that can be deformed, right? So by default, they're this thing. They're perfect hexagons, but they get disturbed for various reasons, including different amounts of energy inside them. And so it's not like a gas because it's packed together, right? And this is what I think it seems like the discrete nature of energy and stuff comes to. It's because of the discrete nature of these cells. So they're particles, but they're really cells. So maybe they can squish and pass through each other. Maybe with enough pressure, the one on the left can slip through the two on the right and make it to the other side and pop out over there. Or maybe the compression is too much. But they're definitely, and they're sticky to each other. Maybe there's some sort of a connection. Because these things, these bubbles are probably, or not probably, but they have magnetic, gravitational, and nuclear energies associated with them, because these have to be the things that are creating those fields. So each of these little cells has an electromagnetic aspect to it. So it's a little, magnetic bubble, which means it might have layers and polarizations and things. It's neutral, empty space, but that could be just like, the neutron is neutral because it has an equal amount of negative and positive charge inside it, which is why it has spin, because since it's got particles inside it that are charged, when you spin them around, it creates a little charged current, which creates an electromagnet. Very faint one, even though overall it acts with a neutral charge. It's just because it's got positive and negative inside it. And these would be similar. It could be that the membrane, the surface tension on one of these cells, for example, was positive on the outside and negative on the inside, but they're so thin that negative on the inside is pulling on the positive from the neighbor, even though the neighbor's positive is pushing on the positive. It could be holding its stasis that way. And that would explain how it could be transformed into so many other shapes, since also it's got a gravitational and nuclear force involved in its mechanism somehow. Now, I could believe that these are purely electromagnetic bubbles and that gravity comes from when the bubble is distorted. If the bubble's really wide, really expanded, and another bubble is compressed next to it, another, bubble space is compressed next to it, that gravity is the fact that the expanded thing has a thinner, less pressure, and the compressed one more pressure, so things are going to tend to travel where it's more spread out and there's less pressure, and that's how you get gravity. How would you get nuclear energy? Well, that comes into something I won't really talk about in detail of answering that, but the idea that when you have bubble space, that's all you've got. You've got bubble space, and the bubbles and therefore space can be distorted. What is a particle? Well, when bubble space has so much energy ripping through it, like might happen early in the universe, according to the high energy beginning of the universe, these things can get burst and forced into other states. And particles are just a bubble state. When it gets so much energy that it bursts or turns inside out, the lining becomes switches in the other way, or it becomes too compressed, or it becomes too. The particles, or not all the particles, the fermions are these bubbles in a different state, I think. Turned inside out or compressed, containing a lot of energy, or multiple bubbles. Since the bubbles were ripped up, when they stuck back together, they became a really big bubble, and that's why they contain so much energy and compress or expand the space around them. Now, the bosons, which is like photons, but there's other bosons, the Higgs boson and stuff, but bosons are like photons. They fly through each other. They're more wave-like than particle-like, but still got the particle aspect because of the discreteness of energy, which really has to do with propagation through bubble space. That's the theory. Anyway, the bosons, I don't think are particles. They have discrete amounts of energy because space is made out of particles slash these bubbles, volumetric particles, bubbles. And so the photon is like if one of the bubbles is jostled by its neighbor, and it bumps 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 its neighbor, and so on and so forth. That's the photon. The photon is the fact that there's the energy, and it's energy, and the energy is at a location. It's wherever the bumping is happening, but it's just mathematically, it's just the distortion of space requiring time to propagate from neighbor to neighbor. Now, so that's definitely like how I think the bosons move through space. Now, when you have a fermion where the bubble has been transformed into an electron or a bunch of quarks that have formed protons and neutrons and things, how does that motion go? Now, it could be two ways. I don't know which one. It could be one of these bubbles here has turned into an electron, say, and then that bubble is, condensed energy, and it can just, maybe it's really big and it could just push through the bubble space, just like if you were swimming around or floating around in a space station in a chamber full of these bubbles. You obviously would just fly through it, and you'd be breaking bubbles and all kinds of shit, and the bubbles would be reforming and going around you, and you'd be going through them. But it could also be that the electron is one of these cells, and the cell actually can't move, but since it's so high energy, it can't inject its energy into the next cell, which becomes the electron. And so you have a cellular chain reaction, an automaton, where basically you're actually translating the electron from bubble to bubble to bubble. It could be either way. We don't know. We know it's one or the other in our theory group. All right, so the final thing I'm going to say is what I was saying before. Is like, it bugs me, this anti-science thing. We're seeing the crime of it with Trump and Rush Limbaugh. I saw this clip. Rush Limbaugh was talking about how people should deal with Fauci is Praise him. The smart guys love that because he was bullied in school. Praise him, praise him. He didn't say the bullied in school part, but praise him. But then don't listen to what he says and just blow him off. And then Trump called into Fox News and was saying the exact same thing. And here's the thing: scientists are just human beings. They can be petty and whatnot, but it's the statistics. It's the data. It's why people that disagree in science end up being able to accept the data. If necessary, they run the experiment that they doubt themselves, and then it all gets on the same table. And when you have people doing that from the outside where we are, you can look in and see which data is legitimately accepted because it's been rerun and understood enough that, hey, this is really how, when you set the dominoes up in this the way this experiment says and you push them over, look what happens. That's what needs to be explained. And then there's multiple ways still to interpret what you're seeing and to explain it. And different explanations might say, well, if that's the explanation, this other thing would also happen. So we set up another experiment to see if that happens. And that's the process. And it works because it's statistical. And people want to go say, he's a scientist, he said something, so I'm going to believe him. No, it's not like a scientist is a priest and all of them are talking to the same God. It's that they're auditors of reality and they're calculators. And overall, there's a statistical baseline that is your best guess, like your best proven guess. It has been calculated. It's your best guess of what's going on. And you got to go with that, if only to compare results to what you've tried. And someone like Fauci is not out there being a maverick creating some unique Einstein when he's 23 theory that we're going to have to wait 50 years to believe in. He's the kind of guy that's collecting the consensus at the time and is meant to represent that for for the federal government, or at least in this, since he's the head of this, in the kinds of things he's been, he obviously has different roles in different pandemics and throughout his career. But, in this case, and what I'm talking about, he's meant to represent a scientific consensus and to be communicating with the scientific community of epidemiologists and all biologists at this time, getting current ideas, but also non-current ideas also that have been reliable, things that have been proven true about epidemiology going back 100 years or more. And so it's similar in the physical sciences here. It's like, Feynman, if he heard my bubble space theory, might chuckle or like it or not like it, or, maybe he would be rude about it or not. It doesn't matter. He probably wouldn't agree with it. The question is, where's the room of denying the data? Einstein spent the last 30 years of his life kind of getting more and more of a crank science where he couldn't get collaborators of the top notch, and he never ended up proving his stuff because in physics, science does have negative monetary influences and stuff, but it's not like with tobacco, finding scientists that they could hire to say tobacco might not be bad for you for 50 years. The whole actual academic field, statistically, they were unable to buy off. They were able to buy off people that they could bring into court. And the person that said, well, most scientists don't believe that, Your Honor, jury, nobody has to believe them if they don't want to. But if you honestly look at these kinds of situations, you can find the data. And so people that insult, Feynman, you could go ahead and still think he was wrong, but to pretend that like he didn't do the experiments. I mean, he invented these Feynman diagrams, which can be used to make calculations, and that's one of many reasons, basically, as one of the founders of QED, quantum electrodynamics, he was able to create a way to do calculations that people then did, and then did the experiments to execute and check those calculations. And that is why people say it's such an accurate theory, is because those predictions are accurate. To pretend like those experiments didn't even happen, he didn't notice it was a parabola, not a catenary. It was, you know, it was a arc of a circle, not a hyperbola. He didn't pay attention to the shape, or he never even looked at the two-slit experiment. It doesn't make sense. And we get this from dissident scientists, not so much from his dad. His dad doesn't go railing off on Einstein. The dissident scientist does. You have Bill Gatey, or Gate, whatever it is. And I just can't get over the fact that that guy was a double agent for the FBI and Cuba. Look up his Wikipedia page, please. It's a good one. Theoria, obviously, and he's one of these people that he hates everybody but Tesla cult. And Menahem is the weirdest one of all, because he's like, I deny being disrespectful of that liar who was either stupid or a liar. I don't I mean, it's like, choose a side, dude. Anyway, bubble space. Mark my words. I'm going to be winning the Nobel Prize for this one, you guys. Sometime soon. Sometime soon. Mark my words, bubble space. It's Batman. Pop, pop, pop. That's just what space is like, you guys. Bubbles that they want to be all symmetric, like over on this side. They want to be like that. Sure. Of course they do. There you go. There's an example. Oh my God. It's a little vacuum in a bunch of matter. Or it's a matter in a little bit of vacuum. I'm not sure which way the metaphor I'm going to go with. Look how distorted that space is. This must be inside a nuclear reactor. I do believe that the cells might overlap. And why? Because of the fact that we have to deal with all the original 5 forces that are now 3 forces, I guess. Gravity, the nuclear, because they think, or have done, not real clear on, they think the nuclear forces, the weak and strong nuclear forces can be combined, just like, not exactly like, but in the same sense that magnetism and electricity, magnetic and electric fields were combined. And so you've got those 3 forces. So maybe the bubbles can overlap, right? You could get really stretched out with the electromagnetic part, but the nuclear part not be so stretched out. On the other hand, I think maybe that the bubble might just be like electromagnetic, or maybe the bubble is gravitational and electromagnetic waves and the nuclear force carriers are, the bubble's jostling, right? It might, but by default, you have to assume that maybe the bubble is a little magnetic, gravitational, nuclear force shell, right? And when it gets twisted in combination with other bubbles next to it in its other states, then it combines into these high energy fermions. Now, I don't think it's like that, because that's not very deformable. Bees, those are my bee friends. So you can absolutely see now how space could be a bubble matrix like this. Obviously, because, the way this bubble matrix works, anything can happen. Really, what's going on is there's bubble fluid flowing through all of these edges, right? And these bubbles themselves, they act as cells, but really they're part of this flowing of the bubble fluid. And if it's in 0G, then the bubble fluid is just kind of floating, drifting around, but it can go through all of these junctions but the bubbles still seem like particles. That's how you get a wave kind of situation. It's this flowing at the edge of the bubbles, whereas this bubble itself is, it's a cell. It has a single identity. If that bubble becomes in some really weird configuration, or not super weird, but just a different configuration, its effect inside the bubble matrix can be very different. And suddenly, this bubble is moving through the other bubbles in this direction. Just as if you were to take a straw and blow air in here, you'd expect to see some of these bubbles flowing and look like they're flowing through other bubbles, when really what's going on is the bubble matrix is just deforming and reforming over time based on what's happening to it. So I'm sure you get the idea and are fully convinced by now. And, I think you guys should probably, you might want to tweet the Nobel Committee. Just saying. You don't have to. I'm not insisting that you do. Just saying it would be smart for you to